Welcome in everybody to another severe weather discussion. This discussion will be focused on the severe threat for Thursday, July 16th. We can see on Environment Canada's outlook here, they highlight a high risk for much of southern Alberta there, slight risk up in northern Alberta, and a slight risk in southern Manitoba. Um, and just general thunderstorm risk across much of central Saskatchewan. And that slight risk also extends into northwestern Saskatchewan near Uranium City. And they highlight the threat for funnel clouds out there as well. So we'll get to the forecast models and take a look at how things are expected to evolve. Before looking at the models, we should take a look at current smoke conditions from wildfires. Uh, some fires going up in southern BC here. You can see on the satellite, maybe better to look at the high resolution imagery here, and you can see kind of near Highway 1 here, we have southwest of Kamloops or west of Kamloops, fires going up. The southwesterly winds could drag that smoke in, and looking at the RAP forecast, we can see some of that smoke moving in higher values near the surface, moving into central Alberta for tomorrow afternoon. Take a look at vertically integrated smoke, and much of the same picture. So this could potentially limit your surface heating, but the threat is for southern Alberta there. So if this is concentrated eastward along a boundary or something, then your unstable air, your pocket of unstable air could be further west. But these vertically integrated values aren't crazy highs, so we'll have to see how it actually plays out for tomorrow. If it's too thick, but overall, yeah, and your smoke from your northeastern Saskatchewan fires, and of course your northwestern Ontario fires. I mean, this is just incredible. This display here, you can actually see the outline of the jet stream here. Very impressive. Very poor smoke quality moving into the northern states, Michigan, Wisconsin, all the way down into the northeast states there. So smoke might be a factor tomorrow. Again, I think the models are the actual observed conditions come afternoon. You'll know how much smoke is going to affect things if you don't really get too many cumulus fields. But we'll have to see tomorrow how that affects things. So we'll move on to the models next. Starting with the 500 millibar chart. This is the Euro here, 12Z initialization. See at here, we'll start at 12Z or 6 a.m. Central Daylight Time tomorrow morning on Thursday. We could see this upper low here that is currently positively tilted and positioned somewhere western Alberta right now, like this. This continues to track eastward, and actually, as of the Euro here has as of 6 a.m. tomorrow morning, kind of neutrally tilted with a stronger flow eastward, and then this kind of southern extension here of that stronger flow. And we could see just animating this. This kind of just stays its same orientation with time, and then maybe starts to move southeastwards, and just kind of brought a stronger flow in northern Saskatchewan here, where that slight risk is located. Come afternoon heating, that you'll probably be underneath the right entrance, or at least underneath the base of this trough. Given kind of the curved shape, you'll probably have just subtle or broad divergence generally out ahead, and maybe subtle subsidence behind it. But I think we'll start mainly looking at your southern Alberta threat here. And synoptically, maybe you have some stronger flow moving through with your with a curved jet streak. I don't know if I'd call this a jet streak, a stronger flow. Yeah, maybe looking. It's just kind of stronger flow. But generally, your divergence aloft would be further west and maybe some weak subsidence out ahead. But again, you do have flow moving over the Rockies, so you probably will have some vertical motion confined pretty tight against your against the Rockies here. And I'm sure that the same kind of picture as yesterday, where you have southeasterly winds pumping moisture northwestward, and of course all the ground moisture near the Edmonton area hasn't really shifted anywhere and won't really be advected anywhere. So moisture kind of pushing up against your foothills here. You have your dry line out here. Uh, the more subtle change in terrain here, where you go from super high elevation to pretty much the prairie, is kind of north of Calgary, and that's where your surface low cyclogenesis will be favored. So we can take a look at that for tomorrow morning. You can see, you kind of have a surface trough along your dry line there, near the Calgary area from the Euro here. It kind of builds in the afternoon, and I'm sure we'll have again some sort of low level jet in place in the evening. And very similar setup to yesterday. In terms of shear, not great today. The storms that are currently going on are kind of super multicellular and clustering. Or actually, here that stronger flow comes in. I don't know what was getting shown before there, but a very good flow out across southern Alberta here. Definitely plenty for supercells. And your thunderstorm initiation mechanism will be the foothills, most likely. We do have most likely thermal advection through most of the day here. We can take a look at the vertical velocity maps. Relatively unmixed air. Steep lapse rates in the low levels. We can see where's our 0 to 3, 8.4 degrees Celsius per kilometer. So the Euro showing plenty of destabilization for southern Alberta. And we could take a look at our kind of synoptic view here. Again, this is the 12-0 for southern Alberta here. You can see maybe some sort of short wave upstream in the morning. You can see enhanced higher humidities through the column here. You get some cyclogenesis in southeastern Washington here along some sort of frontal zone. You can see the higher thickness in moving through. You'd have some sort of cold front or frontal system here. We can try it in our kind of position of the fronts. Maybe something like that for your kind of system that builds in southeastern Washington, and that's moving eastward through the morning hours, and it's kind of going through lots of your lift confined to southern BC here, and that cloud cover that moves in. But again, you have this kind of ridging that comes in here. So cloud cover will probably in the upper levels. You can take a sounding here, and decently dry up there. So maybe some mid-level cirrus, but overall should remain relatively dry in southern Alberta, just east of the mountains there. And you can see the Euro does throw out your thunderstorm development right up against the foothills there, which makes sense. Probably nothing too far east. We could take a look at your temperature, kind of how strong your cap would be, and you do have very hot 700 millibar temperatures down here. But overall, they're pretty low out here in the kind of target zone. Out here, take a sounding. Yeah, very unstable air mass. This is actually quite the inverted V profile. So if storm motions end up being slow, and as that low-level jet starts to get kicking, you will likely see clustering to more clustered modes. But as your supercells start to fire, they will most likely remain discrete, just given that you have a nice perpendicular shear. This is the NAM here. A nice perpendicular shear to your initiating mechanism, which is the mountains themselves and the dry line. So you definitely expect semi-discrete thunderstorms. We could take a look at maybe we could take a look at the HRDPS just to kind of see how it involves convection out there, and maybe the HREF just for kind of mean average helicity tracks. But yeah, we'll look at the HRDPS next. Looking at the HRDPS, this is the 18Z in it. We could see much of the same story, and southeasterly winds really pumping these very high dew points, 20 plus degrees Celsius in some areas. The model fires it south of Nordegg, maybe over Nordegg itself. This is where your stronger mixing is. Your dry line is probably stronger here. Again, your more favorable area for cyclogenesis is in this area here, just because your terrain drops off much more rapidly. But yeah, fires your supercells up here. These would probably be in higher inverted V profiles. Because you just have drier air, so yeah, they'll start off as pretty mixed and could potentially cluster, but yeah, HRDPS goes with that, and then the southern mode, it kind of remains capped here as we have the Euro is showing those warm 700s along that are vected under that ridge that has been building over the western United States, and so yeah, you could remain capped because yeah, if you have advection down there of that warmer air, that could definitely suppress things. But development could still occur if you can break that cap and then remain uncapped. But yeah, very juicy air mass. So if you get storms out here, they could definitely survive. We could take a look at a couple soundings from the NAM. Go for maybe 18Z or 19Z, just east of Calgary here. And yeah, lots of low level destabilization. 3 Cape, mixed layer, 150, so the low levels destabilize quite a bit. I'm sure as you get further north, where your cooler 700 millibar temperatures are, 3 Cape, surface based, quite high, but mixed layer, not so much. This is in some higher terrain here. Your boundary layer is pretty shallow here, as your dry line probably is advected over your moisture. Further south, the capes are a lot lower. Take a sounding just kind of near left bridge. Much more hot and mixed air mass. This is still quite convective. Mixed layer parcels, and you really mix out that moisture there, so you can definitely get storms down there. These would pose very strong winds and large hail. ECC or Environment Canada is showing or highlighting in the high risk, possibly 4 to 7 centimeter hail, so very large hail expected. Maybe take a mixed layer sounding from the NAM here. And we have 900 hail growth zone Cape with your mixed layer parcel. So you'll have enough wind shear for organized supercells and lots of instability in your hail growth zone for very large hail to develop. And this dry air above here will boast and add to that instability, and possibly lead to some very potent downdrafts and I'm sure some very, very fast accelerating storms, if their RFDs really kind of congeal up against the mountains, as is common down there. And yeah, your tornado potential will definitely ramp up in the evening as that low level jet starts kicking. Could take maybe a look, a sounding here. See that moisture might have some drier air moving in, and just overall your mixed layer cape is a lot weaker in southern Alberta. And you see as your low level jet starts to kind of start ramping up, your instability starts to move northward. I mean, take a sounding. Let's go for maybe 8 o'clock Central Daylight Time. You see, start to just stabilize at the surface here. Southeasterly winds. Again, you'll have southeasterly winds through much of the day. Not a lot of storm relative helicity. Yeah, southeast, almost due southeast expected storm motions. So again, if you get further southerly storm motion or faster storm motions or really interactions, so those will be your main tornado producers, because the environment itself is very similar to the environments of the last couple of days. Not crazy tornado environments, but definitely possible. Again, if something goes right on the storm scale, which is pretty much impossible to predict. But yeah, you have supercells, so really that's almost enough. Supercells with very high moisture available to them, and we can take a look at what your LCLs are for your mixed layer parcels that are pretty high, but you see in Alberta, especially up close near the foothills where you have that extra surface vorticity, you can get very tall tornadoes, kind of like Didsbury. The LCLs for Didsbury were about similar, about 1,400 meters. So yeah, definitely a nice supercell environment. Large hail, damaging wind, and non-zero possibility for tornadoes out there. Taking a look at your northern mode, where Environment Canada highlights north of the Fort McMurray area for, let's see here, 2 to 3 centimeter hail, 70 kilometer an hour winds, and 30 to 50 milliliters of rain, and as well as funnel cloud potential up there. Take a look at the Euro. The 18Z just came out as I'm filming this video, so we'll move on to that. You see, through the early morning into the evening, you have this, starts off as maybe kind of somewhat positive to neutral tilt, and maybe slightly ejects to maybe slightly negative, maybe not. I'd say mainly just zonal, but maybe kind of a curved jet streak feature almost up at 500 millibars, maybe at 300 millibars. But yeah, overall, your lift on the synoptic scale here would be pretty much just out ahead of your trough here, and we could take a look at maybe your surface vorticity, or close to 850 millibar vorticity, and yeah, I don't think there's any fronts really out there. It might have a pressure tongue extending from a low pressure in Yukon there. Sorry, Northwest Territories. You'll have warmer advection on the backside, so maybe some sort of kind of warm frontal feature that moves into the area here. Let's take a look at your moisture. Euro showing kind of a mixing gradient here, maybe on a weak sort of front. Again, not really a temperature difference out there. If anything, it's warmer out here, so yeah, I'd probably classify that as some sort of mixing gradient feature here. You can see some sort of low pressure focused out here. Let's take a look at short waves. Maybe some extra energy coming in on the backside here. Moving into the area there about afternoon. 500 millibars. Yeah, I mean, we can take a look at 700 millibar temperature, and it's cooler out there. Take a look at your cape from the Euro here. You can see it builds early up there. I'm sure we have your air mass probably destabilizes early. Let's take a look at 18Z sounding. Yeah, already evidence of heating and mixing out there. So this holograph environment would definitely be supportive of pulse thunderstorms. Not really anything super organized. Take a look at bulk shears, which would likely be higher further south. Maybe take a look downstream here of the trough. And this is interesting. Not like under some sort of cold front almost. Getting your surface features kind of get wonky here. You have Reindeer Lake, and all these lakes here might kind of mess with your soundings. The lakes themselves, especially Reindeer Lake, could be a focus for thunderstorm initiation just because your temperature gradient is so strong. But yeah, this profile might be on kind of the border of supercells. Environment Canada's slight risk area was out here. Maybe take a sounding. And yeah, it's not really a super cellular environment. It might just be on the edge of out of realm for supercells. But maybe some enhanced surface vorticity from Uranium City here, or the uranium. What's the name of this lake? Just checked Google Maps, and I'm surprised it slipped the tip of my tongue there. It's Lake Athabasca. I don't know how I forgot that. But yeah, it could definitely act as a focus for thunderstorms and vorticity along the lake there. But overall, take a look back at your kind of 700 millibar temperatures out in that area tomorrow afternoon. 21Z. And yeah, 3 cape from the Euro. Decent. I mean, yeah, you could definitely see I guess landspout tornadoes out there. Maybe the NAM shows some sort of surface boundary out there better. Take a look. Maybe has kind of a low, maybe a MCV feature. See, this definitely sparked from convection, at least from the NAM's output. See the precipitation associated with that. Don't think this is, I guess it would be Bear Clinic, or at least that vorticity merging with your upper low there. Take a look at that at 2 o'clock. And I guess it's pretty wonky. Right mover, northwesterly right mover, which would be interesting. With those southeasterlies on the north side of that surface low, or upper level low. And yeah, very, very steep level lapse rates. NAM is higher on the 3 capes. Take a look. Just go for most unstable. North of Fort McMurray. And you probably destabilize pretty early. Thunderstorm development would probably be pretty early. And this is a pretty unstable sounding here. Maybe some sort of error with this NAM run here. 350 surface based, 3 cape, 128 mixed layer. So yeah, just those cooler temperatures above the surface there, and looks like some spin near the surface could allow for landspout tornadoes, as well as this spin over spreading the coast of Lake Athabasca, which itself will act as a source for vorticity out there if any thunderstorms can ride uh, this temperature gradient here. So overall, you could have small hail if you get kind of pulse semi-discrete thunderstorms. If you take a look at things with cluster, again you have lots of inverted V's profiles. Doesn't really look like you have like crazy moisture advection, and the forcing doesn't seem to be insane either. We take a look at Euro for 700 millibar vertical velocities, and you have a stronger response downstream here. Let's see, maybe lots of activity further east. But overall, synoptic forcing probably won't be insane underneath your upper kind of upper level low. So yeah, you can definitely see the decent thunderstorms. You could maybe just barely breach the supercell category. Maybe with some just slight enhancements to bulk shear on the mesoscale. But yeah, could be interesting out there. Overall, smallish hail, strong winds, and possibility of landspout tornadoes further north, as Environment Canada highlights here. And they're even going for Lake Athabasca up there, which I haven't read the discussion, but they could be going for that as their reason for landspouts, and combined with the strong level destabilization and strong level instability from 0 to 3 kilometers. So yeah, overall, we can take a look at the HRDPS output here. Kind of see here. Yeah, you can actually see. Yeah, overall, kind of get thunderstorms, maybe some sort of boundary. I don't think I would call that a cold front. Maybe a warm frontal feature. Maybe you have just a weak wave. Where'd my pen go? Here it is. I don't know. Maybe something like this. Like it would be maybe an occlusion actually. It's given your upper level low position. It's kind of like a warm front, so I don't know. Maybe your occlusion won't extend that far. It's something like, I don't know, something like this, possibly. A very weak cold frontal feature. Yeah. It's kind of hard to find. This energy out here is from current thunderstorms that are that are forming today. Yeah, maybe the upper level water vapor will give us a better view. And synoptically, your cold front should be back here. Occlusion, warm front. We'll definitely have isotropic ascent further east, which kind of fits that synoptic definition of your synoptic scale fronts, and your precipitation pattern definitely follows that. So yeah, I would call that feature further west, cold front, and yeah, so that would be your initiating mechanism and also just for general thunderstorms further south into the province. And yeah, we can see the high pressure still stays down there. We take a sounding from down there, 21Z. yeah, large scale subsidence still working on your profile, so yeah, you'll probably be limited in thunderstorm activity the more south you go to Saskatchewan. But yeah, overall, just could see stabilization underneath the dry slot of this larger scale cyclone here, and just decent thunderstorms overall. So yeah, we'll look at southern Manitoba next. For southern Manitoba, Environment Canada highlights another slight risk: 2.5 to 4 centimeter hail, 40 to 60 millimeters of rain, and 80 kilometer an hour winds are possible. Let's take a look. Let's just go back to the Euro here in terms of your synoptic picture. Kind of see maybe your fronts kind of meeting up here, going to Thursday afternoon. Overnight, you have kind of this cold frontal feature moving into Montana, and your low level jet will pick up, and you'll get isotropic ascent continued into southern Manitoba, and eventual dry air moving in eastwards. Overall large scale ridging aloft here, and you can see that short wave. This is 300 millibar geopotential heights and 500 millibar vorticity, so that short wave doesn't really extend above into 300 millibars. But you can see it's responsible for initiating connection overnight, elevated along your roll of the jet that will develop. Thunderstorms probably. Let's see if there's one that destabilization starts back up. Here's 9 o'clock, and you can see your frontal inversion here. Temperatures increasing with height. Your looping photographs indicative of warm air advection. And it's okay. Your most unstable parcel from the Euro here doesn't really have too much instability associated with it. You can look at the NAM, kind of the same area. And definitely a warm frontal, warm air advection zone. Let's go back out here. Take a look at 850 millibar temperature advection. And there's lots of temperature advection to southern Manitoba. That will be your main initiator. Besides this, you can even see some sort of cold front that moves into southern Manitoba, and you have your frontal wave, something like this, and then your kind of frontal feature moving like that into southern Manitoba. So let's take a look at your parameters for this environment in terms of severe potential. Overall, it'll probably be a pretty messy environment, just given the degree of synoptic ascent. This is the NAM again. Let's look at surface-based cape. See, it kind of struggles to build. It does build into southern Manitoba. Take a look at where you kind of hit that warm front transition, and it would be kind of north of the Brandon area here. Maybe something like, I draw this in. Something like this would be your warm front, based off of where your surface instability changes to upper level instability. Take a look at here, and that highlights a pretty good picture. Probably further south here on this wind shift. Let's take a look at this kind of unstable part here. It's 5 o'clock. And very large looping photographs along that warm front, as you would expect. You remain capped as you advect that warm ridge air into the region here. So you might struggle to get surface-based thunderstorms. In terms of your elevated thunderstorm threat, I would take a look at that. Look at center vorticity. On the large scale, you might have some breakdown of that ridge further west. but overall probably neutral synoptic scale ascent, mainly driven synoptic or isotropically, not really kinematically. If anything, kinematically, you'll have forcing for descent. Take a look at your 700 millbar vertical velocity field. And see a lot of that associated with that convection that develops in a low level jet. And yeah, just kind of weak, if not negative. And again, yeah, your frontal wave will likely be will be your focus for surface-based convection. Which honestly, if it develops down there along that warm front, could be pretty interesting. It depends how far north that gets into southern Manitoba. But if you do get sustained surface-based convection along that warm front, it could even have tornado potential. But it seems like the NEM might be the outlier. Again, you would be capped. Surface-based parcel and mixed layer parcel have quite the difference. So, yeah, maybe some elevated supercells just north of that warm front, which might have a decent look on radar, but would most likely be elevated. But taking a look at your elevated thunderstorm threat, your parcels, unstable parcels would be roughly 3 kilometers. So taking a look at your 3 kilometer vector there, would be about it wouldn't have too much shear. I would guess if we were to kind of center your 3 kilometer vector as the kind of relative spot, 3 kilometer winds are about 20. I guess let's take a look here. About 15 knots. Mean wind is about not too much above that. About 20-ish knots. So above that, you're kind of subtract the motion here, and you have 60 knots, so minus 20. Your parcels that would be unstable would be feeling about 40 knots of shear. Not a lot of instability, so you could get maybe more organized thunderstorm development in this zone. I wonder with that dry air overspreading further west. You can take a look back at the Euro here. You do have dry air moving over that zone, so it could have conditional static instability. We go from moist to dry above that, and if your momentum, you have wind shear increasing with height, so you could have precipitation bands developing parallel to your thickness gradients here, which could, in some cases, if you do get conditional or slantwise instability to develop, you could have localized strong precipitation bands, which would not be good for southern Manitoba, as you would not want more localized rainfall down there. But overall, your surface-based convection really depends how far north that warm front gets, and if you remain uncapped along it. And look at the GEFS. Take a look at your mixed layer cape. You can see to kind of get an ensemble view. Maybe it actually does get a fair amount north. Still pretty low values. Your higher values, the 18Z, are just along the border there into North Dakota. So if this does get advected further north, you could see maybe be seeing a more substantial threat for southern Manitoba. You can see the mean supercell composite just barely extends into southern Manitoba. So yeah, mainly an elevated thunderstorm threat, and be an isotropic mess with lots of stratus moving in, nimbostratus clouds. Yeah, it's a very rainy day for southern Manitoba. It appears here. We can take a look at your total QPF. It does develop kind of on the edge of your low-level jet, which I would assume would persist through most of the day here, somewhat, 13 knots. and then ramps up in the southeastern Manitoba, where your precipitation will probably start to ramp up again. Take a look at 6-hour QPF, and yeah, so it's to ramp up at the tip of that low level jet in the nighttime hours. Yeah. If you get conditional static or slantwise instability bands to develop parallel to your thickness contours, you could see localized pretty heavy precipitation. Maybe take a look at the HREF, which might resolve that better. And yeah, you could see some pretty localized precipitation bands. Hopefully this stays away from the Brandon area. Do not want that to develop. Yeah, overall, it appears some static or slantwise instability does develop. And you get these bands, which may be pretty random. But to get an ensemble view, it shows them just missing Brandon, which is what you want, as at least from the 12Z. Take a look at the runs here, and it's pretty consistent. Actually, maybe a downtrend, which is a good thing. Downtrend further north of Brandon and further south. So Brandon might be straddling right in between these two modes, and hopefully doesn't get more precipitation. Yeah, thunderstorm threat looks like mainly an elevated threat. If you do advect higher, I mean, you could have enhanced instability further north, so it would add to convective instability. Your convective instability doesn't appear to be crazy high. Getting again, I guess, a mean average picture here. Mixed layer does extend somewhat. Most unstable. Yeah. Just overall kind of general thunderstorm threat for most of southern Manitoba, but mainly elevated. Yeah, and there could be lots of rain. Unfortunately, localized heavy rain that would develop in kind of east, west northwest to south southeast, or east southeast oriented bands that would develop. The ensemble showing north of Brandon, possibly south of Brandon. So could get hairy out there in terms of precipitation. But overall, your thunderstorm threat doesn't appear to be too strong. Just take a look at the cams, the HRDPS output for out there. It's right here. And pretty interesting here. Your HRDPS actually goes for like upscale growth along your surface cold front would kind of end here. Low level jet would be kicking up here. This honestly isn't really the picture that I would think that this kind of environment would produce. It does show a north to south oriented line. Going back to the ensemble here, we could see maybe lightning probability for maybe the orientation of your thunderstorm development. And yeah, I'd probably trust the look at we can maybe look at precipitation, mean composite reflectivity. Yeah, I would expect more of this picture northwest to southeast. Not really sure why the HRDPS is throwing that north to south oriented band. Maybe it has more low level destabilization or surface based air, unstable air further south. So maybe it's going for upscale growth along your frontal feature or trough for surface based storms. Unfortunately, can't get any soundings from the HRDPS, so not really sure what it's going for down there. Maybe I guess quickly we could just put on surface based cape. Let's see. Yeah, I mean it develops right at the tip there, so interesting. I wouldn't really take this one model run to show an accurate depiction storm evolution synoptically, and along your zone of slantwise instability that will likely develop. I would expect northwest and southeast oriented convection, to speak in terms of averages there. And I guess we can end off with the GEFS probabilities here for your different hazards. Let's go for day 2. This is 18Z, so here we are, day 2. And we can see in terms of probabilistic terms, lots of development along your kind of quasi-occlusion, pseudo-occlusion thingy further north. Cold front that arcs west. It shows pretty low probs for southern Alberta there, which is interesting. Again, you have that ridging, which even the model show quite a bit of spread here. You can see in this kind of spaghetti plot of your jet, quite a bit of spread in this ridge. And yeah, GEFS pretty low on probs. Maybe take a look, just a quick look back at your lightning probability from your href. You see afternoon, so that ridging might kind of keep things quiet in southern Alberta with your warm 700 millibar temperatures being advected in. So yeah, things will be kept to the foothills mainly for your Alberta threat, and will transition to higher tornado potential into the evening as storms can survive. But on a more probabilistic sense, you're definitely more likely to get storms further north with low-level destabilization and subtle forcing further east with that kind of frontal feature, and oriented in a kind of extratropical sense, where your extratropical fronts out there, warm front east, cold front west, occlusion north, and it does pick up pretty good on a thunderstorm development in southern Manitoba, and especially into the evening as that low-level jet picks up, and even showing hail potential for southeastern Manitoba at nighttime there. So overall, kind of a broken record for the foothills. Again, you just have this moisture that's pooling along the dry line. We have this high pressure in south central Saskatchewan that will keep moving eastward and will keep bringing southeasterly winds, and will allow moisture to build into the foothills, and as well as that canola sweat that keeps pummeling moisture eastward, and of course all the rain in north central Alberta near the Edmonton area. So overall, just lots of storm fuel that has persisted over the prairies and will keep persisting. And your upper dynamics aren't super impressive, or maybe necessarily what you'd want to see for southern Alberta, but so you may struggle to get storms again. That could be a kind of a trade-off there. You'll struggle to get storms, but they could be more semi-discrete. So if you want to get a good lightning show or a good supercell show, tomorrow would be a great day to go out and chase. And even a non-zero tornado threat, if you get favorable storm interactions, and the storms can persist into that low-level jet time. But yeah, overall, another day of active severe weather for the prairies, and more to come for Friday and into the weekend for the western prairies. So that will be all for this video. Thanks for tuning in, and we'll see you next time.